Question 5C is asking us how long until the rock hits the ground. So we've already been doing parts of this problem. We found how high the rock went. We figured out how long it took to get to the maximum height. Now we want to know how long the rest of the trip is going to take and how long from when it leaves the man's hand until it reaches the ground. How long will that be? So we've already analyzed this upward portion of the rock flying through the air. Now we have to look at this whole flight down to the base of the cliff. Okay, and once we have the time for that blue part of the path, we can then add that to the time we found for it to reach its maximum height. So let's do a little work on here. We're gonna start like we always do. We already have our diagram done, but we're gonna write some of these givens now because the givens we had before don't apply, or some of them don't apply anymore because we're looking at a different portion of the path of the rock. So our V initial is no longer that initial when it left the hand. We're only looking at the blue portion. So it's going to be the initial at this top, which is 0 meters. It was the final for the green path, and now it's the initial for our blue path. Okay. We also know, as always, that the acceleration is 9.81 meters per second squared. I want to just point out, notice, for both paths, that's still negative for both of these. Gravity doesn't change. It doesn't change direction, and it doesn't change depending on if something is falling upwards or falling downwards. Okay. Now, what else do we have? You might not see it in the problem if you're just reading through the problem. We know the height of the cliff is 20 meters, but it's falling from higher than that. But we can figure out the displacement because from our original problem, we know that it traveled 20 more meters, 20.39 more meters above the height of the cliff. So based on this calculation, that tells us that this height above the cliff was 20.39 meters. Notice how I'm adding details to my diagram as I go. That's always helpful. And my diagram isn't actually proportional. It's a little confusing. It looks like that's much shorter than the height of the cliff, but in fact, when I first drew it, I didn't know that that was going to be bigger than the height of the cliff. So both of these are would be added together for the full displacement. But don't let yourself get confused because you might have something that looks smaller. Remember, you might not have known that when you first drew your picture. So according to my diagram now, I see my displacement is 40.39 meters. That's the whole length. And don't forget, we're starting from above and we've gone down, and displacement always has a direction. So we have negative 40.39 meters. So now they're asking for t, time. And that's our unknown. At this point, these 4 variables are the only things that we have. So we have to think about which equation can we use. So let's write them out. V final equals V initial plus AT. Okay, so that's good. That has t in it. That's what we're looking for. It has acceleration. Okay, we have that. It has initial. We have that. We don't have V final. So let's write some of the other ones and see if we can use those. V final squared. I can already tell that we also don't have V final for this one. Squared plus 2AD. And this one also is not good because we don't have the final, but it also doesn't have t. So this doesn't even get us the part that we want. So let's just remove that completely. And our other equation is our displacement equation. Now d equals v initial times t plus 1/2 at squared. And if you look at this, we have all of the parts. We have the displacement, we have the initial, we don't have the time, but that's what we want, and we have acceleration. So this is great. And this should look pretty familiar. We've done a bunch of problems where we hold an object and we drop it. So when we drop something, it starts with an initial velocity of 0. And when something falls from its maximum height, it also has an initial velocity of 0. So we're going to plug in our givens. Equals v initial is 0 meters per second times t plus 1/2 negative 9.81 meters per second squared time squared. So we get negative 40.39 equals our 0 term, our t term goes away. 1/2 times 9.81, you get negative 4.905 t squared. We're going to divide both sides by 4.905. Negative 4.905. Let's get our calculator out. And we have 40.39 divided by 4.905. And we get 8.23 seconds equals t squared. Don't forget your squared. And now, to get t itself, we have to take the square root of both sides. So let's just punch that into the calculator as well. Take our last answer, find a square root. And it turns out that this is 2.87 seconds. So that's the time of our downward portion of our trip. Okay, so that's only the downward portion. We have to go back to our original, part B. So part B of this problem, we have 2.04 seconds. So that was our upward portion. And we have our downward portion. And when we put those together, our two times, we get 4.91 seconds is our total time. That's including upward and downward portion of travel.